Hello everyone, welcome back to the channel. So today we are going to see how we can train our machine learning model and then how we can do predictions with that model and then how to associate or deploy to our REST APIs. So let's get started. Before starting, I just want to let all of you know that I have written an article on the same topic. So you can go and view this page. I have tried explaining all the points in details. It has prerequisites, structure, and all the commands that I'm going to use here. So you can visit this particular link and see how you can implement it yourself. So let's get started. So nowadays, if you see, a lot of people are using AI. I mean, mostly use ChatGPT, agentic AI and other stuffs. But not everyone is able to create their own machine learning models and use it with their APIs. So today in this particular video, I'll explain how to do that. So let's get started. This is my Visual Studio Code. I will first explain the project structure, what I have here. So if you see, I have, starting from here, I have front-end application. So for this particular use case, I have created front-end as well, just to showcase how it looks from the user input perspective. Then we have a app.py, we have a details.txt. Then this is a file loan sanction assessment.py. Then we have a model created here. And then we have a requirements.txt. These are the major modules which are required. For now, I'll remove this file. Okay, so let's get started with the application code. This is a file which is actually training our model and saving that model to a package file. So if you see, we have used few libraries from Python, which is first is pandas, used for importing the database, sklearn for model selection. Then we have used three different models: decision tree, random forest and logistic regression. So we are training our model on all the three of them, and then we are finally deciding which one to choose. I mean, whatever gives the most accurate result, we'll use that model and we'll save it. Then I'm also using this job lib to save my model and label encoder to actually do the encoding for each particular rows, columns in my data set. So before starting, I wanted to show you my training data set. So this is my data set. If you see, I have few of the columns here like loan ID, gender, married, dependent, education, self-employed, applicant income, co-applicant income, loan amount, and all those things which are mandatory. And the final one is our loan status, either it is approved or not. So this is my training data which I am going to use. I'll first explain the code in detail. So here if you see, I'm taking this data set using pandas. Once I have my data set imported to the application, I will be fetching out the important columns from the data which is actually used for training purpose, for my model training, because there are a lot of columns which are not required, right? Like either it is married or not, or what is the gender. So these things are not directly required for our training purpose. So we have fetched only the mandatory ones, and then we are using label encoder to encode them. Once data is successfully imported and the required data is filtered out from that complete data set, what we are going to do is we are going to mention what is our training and what prediction we are doing. So here if you see, from column number 6 until 11 or 10, I'm picking it and I'm training based on that only. So if you see here, from 6th, starting from income to loan status, I'm picking and I'm saving it into an array. And then the final one where the actual decision has to be made is saved into Y. Now I'll tell you how the data is getting splitted into two parts. So if you see, 80% data will be used for the training model and 20% will be used on the same model, trained model, to predict either it is matching or not. And the predicted result will be compared to the actual results to get the accuracy score. So here if you see, I've used first model, my logistic regression model here, and it will initialize the class with max iterator 500, and the model will be created like this. Now coming to the training section, we are going to use model.fit object to train it. We are passing our X train and Y train. So I'm going to use my X train and Y train here to actually train that model. which is my X and Y here. So if you see, X is the columns and Y is the decisions. So based on X, Y will be predicted. So that's how I am passing it into my model. And once my model is ready, once my model is trained, I can use that model to predict the rest of the test cases, which I have taken here. I have split it 20% of the data for testing, right? So that testing data I'm going to pass in the predict function, and this will predict the actual test data and save the result in predictions variable here. And then we are finally printing the data. Similarly, I am doing this for decision trees. In decision trees, if you have little bit exposure to the graphs, you should be able to know how decision tree works. It has a root, and based on the decision, either if it is yes, it is going to left side. If it is no, it will go to right side. Something like that is what tree structure is. Tree based structure is in decision tree. So here we are using decision trees to decide. Same thing we are doing here also. We are creating a model too, and then we are using our training data, X train and Y train. We are once training is done, we are again doing the testing, same testing, and we are predicting the result. Now coming to the random forest. Random forest is a group of decision trees. So here if you see, I'm passing n estimators in the initialization of this constructor. So I am passing 100 value here. It means that based on 100 decision trees, the random forest is going to work, meaning it will have 100 decision trees, and based on the average of that result, it is going to predict, which is more satisfying and more accurate compared to others. So once that is also done, I am going to print that prediction result. I have already done that comparison before, so I am going to directly dump it. I mean, using joblib.dump, I am going to dump this model into my loan model.pkl file. Okay, and here I am going to actually predict with some different data also. I mean, this is additional which I am doing here, which is not mentioned in that article, but just to compare with the full data, how much accuracy rate I am getting. So basically our requirement is these two percentages which we are creating here. Now I will run this particular file and show you how this loan model.pkl is getting created and saved into package. Okay, so before starting, I just want to let you know, whatever we do, it should not affect our normal system. So for that, it's a best practice to set up a virtual environment if you are going to do anything, because whatever libraries you are going to pull for this particular operation, they are little bit heavy and may slow down your computer. So what you can do is you can create a virtual environment. Once your application is done, you can directly delete that file. So all that libraries, whatever you have pulled, will also be deleted with that once the use is complete. So I'm going to tell you how to create virtual environment now. So before creating virtual environment, we just have to make sure Python is installed in our computer. So I have Python 3. I'm going to check the version now. Python 3 version, Python 3.1.0 is there. So I'm going to create that environment now. You can have Python 3.8.9 or more. So this is the command to create a virtual environment. So you see now venv file got created here. So this is a local folder which got created into my directory where I'll be installing or doing all my operations. So once this is created, you can switch your command line to venv, your virtual environment. So this is a command to do that. Source venv /bin/activate. So you see now venv is activated now. Now once this is done, next step is to pull all those libraries which is being used here, like whatever we are importing here, to pull these libraries is the next step. So for doing that, we are used to store all our dependencies in requirements.txt file. So here if you see, I have pandas, I have scikit-learn, joblib, Flask and Flask course. So Flask and this one is used, Flask course is used for API building. That is the next step. So what I'm going to do is I'm going to write my next command to pull all those libraries. Pip install -r requirements.txt. So now if you see, all my libraries are getting downloaded into my virtual environment, not in my direct PC, into my virtual environment. I have cleared my terminal so that it will be more readable. Now once all the dependencies are already installed in my virtual environment, I am going to run this particular file to create that package. So I'm going to run it, Python. So I'm just running this particular Python file. Yeah. So for me it is running little faster. For you it might take some time. Also since you are running for the first time. So if you see, this is my testing prediction from my 0.2% of maybe 20% of testing data. So my logistic regression has returned 80%. My decision tree has returned 76% accuracy, and my random forest has returned 83% accuracy. And as I told, the final one I'm going to again predict with the complete set of data set with my final created model, which is my random forest. So it is kind of the full comparison between one training data and the test data. So that is come out to 96% of accuracy. And also see, if you see, as part of this application run, my loan model.pkl file again got created, which we are going to use in our REST API. So that is one part of training and saving your machine learning model. Now coming to the next part of creating our Flask API. So if you see, I have created this app.py file here. So in this particular file, so app.py is used for writing our REST APIs, and this is the entry point of any Flask application. Here also I have used Flask. I have imported Flask, joblib, numpy, and Flask cores. So here if you see, at the very first stage, what I'm doing is I'm again using that same model. I'm loading that model to my class, and that training part is a one-time activity which you can do, and you can share this packages file with multiple people or within multiple applications. And this is how we are going to import it in our API. So once the model is loaded, we are going to create a API. So if you see, this is a post operation that I've created with predict endpoint. And as part of payload to this particular API, I'm going to accept these many columns or variables, and based on this, my model is going to predict. So if you see here, this is my features array which I have created. Okay, and using this itself, I'm using numpy here, and based on this, it will predict. My model will predict on these features and get the approved or not approved status back to me. So this is what my model is going to do. Now let me show you how to run this Flask application and expose these APIs, and how to test it using our Postman or any third-party tool like that. So the command to run it is python -m flask run. This particular command will automatically pick my app.py file, and it will run my Flask application. Now you see, my application is started in 5000 port, and this is the URL. Now I'm going to open my Bruno application. From here I'm going to trigger my API. So this is my API which is exposed on 5000 port, and it is expecting this kind of payload. So here I have created this payload in method body, and I'm going to call this API now. So if you see, based on these values, applicant income, co-applicant income, loan amount term, and credit history, it has predicted the options for me. Either it is approved or not. So if I try to change some values, see, the prediction will automatically change. And again, I'm repeating, this is not a rule-based system. It is a machine learning model which is actually predicting that either it is approved or not. There is no rule that if this value will be below to this particular amount, then it will be approved or rejected. It is completely prediction which is happening here. Now I showed you how to run this particular part from third-party tools, I'm also going to show you how you can use your front-end application to take these values from user. So I have already created a front-end application here. As you can see, you can create a ReactJS application to run this particular file. This is my standalone page which I have created, and I have included my API call also here. And based on that, I am taking some user inputs and then predicting the results. So I'm going to show how this actually is running. So I'll use npm start to run this. My front-end application started successfully. Now I'm going to show you how this is looking from front-end perspective. I'll go to a new tab, open my localhost 3000 port where my React application is running. See, this is my React application. And I'll also open my network tab to show how exactly API call is happening. So here you can provide information like applicant income is 5,000, co-applicant income is 1,500, loan amount is 200, loan term is 360 days, credit history is good. For now I have put it as Boolean. And you see, this is the API call which is getting triggered with this button, and this is my URL to backend Flask API. Then this is my payload which I'm passing as an object, and then this is a response which I'm getting from my machine learning model prediction, and this is how I'm showing it here. So this is all about how you can build your own machine learning models, and you can include them or deploy them with REST APIs. In this case I've used Flask. You can also go for fast APIs. The steps are very much clear, and detailed steps are available in this article. I'll put this link in my description. You can go and see that particular steps, how it is actually working. So thank you everyone. Hope you had a good learning with this particular video. Please like this video, subscribe to the channel, and please comment your queries if you have any. Thank you so much.